Okay, in this video I want to talk through two rules. One is negation introduction and the other is negation elimination. I'll talk through the form of the rules, then I'll talk through some more intuitive explanation of the rules, and then I'll deal with some kind of frequently asked questions concerning them, and then do some examples. So negation introduction, let's just kind of read the rule here. It says that from a derivation of a proposition Q and its literal negation not Q. So what we're doing here is reasoning into Q and the literal negation of Q, which is not Q. So Q and not Q can be any formulas. They just need to be literal negations of each other. So for example, you could have, let's say you reason to P and not P instead, or Z and not Z instead. So you, from a derivation of Q and not Q within a subproof, so we're reasoning under assumption that involves an assumption P, we can derive not P from the subproof. So let's take a look at this. So here we have our rule where we first make an assumption and we can assume whatever we want, but here P is assumed. Then we reason at some point in the subproof to Q and not Q. We reason to a formula and its literal negation. And then from this entire subproof here, we can reason to the negation of the original assumption. So we assumed P and then we're able to derive not P. You'll notice that this is an introduction rule, and the type of formula that we're introducing or bringing into the proof is a negated formula. So that's why it says negated introduction. Another thing you'll note is that when we cite the lines that we make use of to derive this formula, we want to cite the entire subproof because we're reasoning from this entire subproof that begins with P and ends with this Q and not Q. And then from the subproof, we're deriving the negation of our original assumption. Let's take a look at negation elimination, and then we'll talk through these two rules in more general terms. So here's negation elimination. Negation elimination basically says the same thing, but there's just one small difference. Again, we derive a formula Q and not Q within a subproof. And in this case, it starts with a negated formula. So since it's an elimination rule, this means that we're reasoning from a formula of a particular type. And in this case, we're reasoning from a negated formula. So it says from a derivation of Q and its literal negation, not Q, within a subproof that involves the assumption not P, a negated formula, we can derive P from this particular subproof. So let's look at the argument structure or schematic right here. So here we begin with the assumption not P, which is a negated formula. We reason to a formula and its literal negation. So in this case, we have Q and not Q. But remember, this can be any formula and its literal negation. So it could be, let's say, Z and not Z. And then from this entire subproof here, we're reasoning to P. That is, we're reasoning to a formula that involves the removal of one of the negations, that is the main negation in the assumption. So we assume not P, reason to Q and not Q, and then from the entire subproof, we can reason to P. Again, since we're relying upon this entire subproof, we'll use all of the lines of the subproof. So if this were line 1 and this were line 7, we would cite negation elimination lines 1 through 7. Okay, now let's talk through these two rules in more general terms. But before we do that, let's look at an example. So here's an example that will make use of negation elimination. So the proof here starts with P and not P, and then they're asked you to derive Z right arrow R. So we start the proof by assuming not Z right arrow R. And you'll notice that our assumption is the literal negation of the formula that we want to derive. And since we're planning on using negation elimination, you'll notice that the formula that we're assuming is a negation. So we make this assumption here at line 2. We derive 3 from line 1 using conjunction elimination, and line 4 comes from line 1 using conjunction elimination again. So what have we done in this subproof at least? What we've done is made an assumption and then derived a formula and its literal negation. So now that we've made this assumption, derived a formula and its literal negation, we can reason to a formula which is the assumption except for it no longer has this negation. And so we can reason to Z right arrow R using negation elimination, and we'll, in terms of the lines that we made use of, it was lines 2 through 4, which is the entire subproof right here. Let's talk about these rules in more general terms. So negation, elimination, and introduction are sometimes referred to as species of reductio ad absurdum, or arguments that have this kind of reduction to absurdity. The idea here is when you make an assumption and then you show that a contradiction follows, that is P and not P follows, you've taken that assumption and sort of reduced it to absurdity. It's also sometimes referred to as a kind of proof by contradiction. That is, you prove something by showing the opposite yields a contradiction, that is a formula P and not P. Both are sometimes referred to as indirect proofs, in that they try to prove something by showing the opposite, by assuming the opposite proposition, and then showing that opposite proposition, which is the negation of the formula you want to derive, leads to a contradiction, that is Q and not Q. So one question you might have immediately before I'll deal with this question again, is how you would use these formulas in a kind of everyday life argument. So let's take a look at an example. So let's look at a concrete example involving the use of negation, elimination, and introduction. So let's say we start with some premises. These are propositions that we'll accept to be the case. Maybe we do believe in these propositions. Maybe we're just kind of committed to them in an argumentative context, but nevertheless, we're going to accept them as true. So the first premise 1 here, is that if God exists, we're not saying God does exist, but if God exists, then God is all-loving, all-knowing, and all-powerful. The second premise is that if God is all-loving, all-knowing, and all-powerful, then there should be no evil in the world. So no evil in the world. And our third premise here is that there is evil in the world. So these are propositions we're going to accept, and then we're going to reason from them. Now, let's suppose you don't believe that God exists. You're committed to this view that there is no God, and you want to prove this. So God does not exist. That's what you want to establish. And you want to show that this formula follows from these premises. You want to show that you can reason using these premises up here to the proposition that God does not exist. Here is a case where we might use the negation, elimination, and introduction rules. In particular, we'll use negation elimination. So let's see how this works. We'll start by assuming the opposite of what we want to prove. So since we want to prove that God does not exist, we are going to assume its negation. So we want to assume that since we want to prove that God does not exist, which let's just call not G, we're going to assume the opposite. That is, we're going to assume that God does exist, which we could call G. So it's important to note that we are making an assumption that is based upon a conclusion that we want to establish, but rather than assuming the conclusion to be the case, we're assuming the opposite, that is the negation of the conclusion. This is the formula that we are assuming. We are assuming that God does in fact exist. The next step is to show that if we make this assumption, a contradiction will follow. That is, under the assumption that God exists, this leads us to some type of inconsistency, some commitment to a formula and its literal negation, or a sentence and its literal negation. And the idea here is, yes, if we assume God exists, then using these premises, we can reason to the sentence, there should be no evil in the world, or there is no evil in the world, and there is evil in the world, which looks like we're reasoning to not E and E. So the idea is if you make this assumption that God does exist, it entails both a formula and that formula's literal negation. Given that we can reason to not E and E, that is, under the assumption God does exist, it means that there is no evil in the world and there is evil in the world. We can make use of the negation, elimination, and introduction rules. Under the assumption that God exists, if it entails this contradiction here, not E and E, we can reason to the conclusion that God does not exist, which is the negation of our assumption. So you'll see what happened here. We wanted to prove that God does not exist. And so we started by assuming the opposite of what we wanted, showing it to be contradictory, and given this contradiction, the opposite of G has to be the case. That is, not G, or God does not exist, have to be the case. Now, I want to kind of point out here, I'm not committed to this particular argument. I'm not trying to make a kind of atheistic point or a theological point. I'm just using it as a kind of way of illustrating this type of reasoning in everyday life. So now it's time for some frequently asked questions. People ask me a lot of questions about this particular pair of rules, and so I want to go through some of them here. So the first question is, what should I assume when I'm making use, if I want to make use of negation, elimination, and introduction? And my answer to this is you're always going to assume the opposite, that is the negation of the formula you want to derive in the proof. So if you want to derive P, this is like, let's say the conclusion of your argument, then you'll assume the opposite, which is the negation, which is not P. If you want to derive P and Q, then you'll assume not P and Q. And if you wanted to derive not Z, then you'll assume either Z, which is not Z and Z are literal negations of each other, or not Z, which is just another negation tacked onto not Z. Another question I get is once people have a pretty good grasp of, okay, I understand I always want to assume the opposite or the negation of what I want, they'll say, well, when is it a good time to use these two rules in a proof? Let me give kind of two answers to this. The first is when you can identify that the premises in the argument are inconsistent. That is, you can use the elimination rules to derive a formula like P and not P. So the tactic here in a proof would be to, if you have a set of formulas that you're reasoning from, you simply use the other rules that you have to derive phi and not phi, or a formula and its literal negation. Then you'll go ahead and assume the opposite of the conclusion, and you can reiterate phi and not phi into the subproof, and then use either negation elimination or negation introduction, whichever one is pertinent here. Another general answer is, well, if you're not really sure what to do, that is, you've used all your elimination rules, you've tried different ways of proving it, but you haven't quite yet used this negation elimination introduction strategy, and you've simplified the proof as much as you can, maybe it's time to look at the goal of your proof and say, well, what is my proof trying to establish? Let's assume the opposite and then work with what I have to see if assuming the negation of the conclusion gets me what I want. So the idea here, or the strategy here, would be to assume the opposite of the conclusion, then see if this assumption will allow you to derive a contradiction, that is phi and not phi. If it does, then you can use either a negation elimination or negation introduction to solve, or whichever one applies in this scenario. Another question I get sometimes is that sometimes people will always try to use these two rules. And so they'll say, well, when should I not use it? One would be when you don't really have a clear reason to do it, or you can make use of elimination rules to simplify your proof further. So just using it to use it obviously doesn't make a whole lot of sense. If there are other rules that you say, hey, this would allow using conjunction elimination or conditional elimination will get me my conclusion, then obviously maybe using negation elimination or introduction isn't the most efficient proof solving strategy. With that said, I do see some people who make use of this particular rule quite a bit. And so if you are comfortable using it and you take it as general strategy, then it's a powerful rule to use. Another case when you maybe should not use these particular rules is when your conclusion is a conditional. In these cases, it makes more sense to use maybe conditional introduction rather than negation elimination or introduction. You'll notice that conditional introduction will introduce into the proof a conditional, and so it seems like the more straightforward rule to use when you're trying to derive a conditional. Another question I commonly get is, when can I use these rules in daily life? Now, this type of question I think is outside the scope of my expertise, but I want to kind of give a general answer to it anyway, just because it comes up so often. So my first response to this is practically, that is when you should use it. It's really hard for me to say when you should or shouldn't use it, whether it makes sense to use it in the workplace or a social situation or in your personal life. Because what you're doing is showing a particular viewpoint or position or proposition to be absurd. You're showing that it entails a formula that is a sentence or a proposition and the opposite. And so I think one kind of reaction that I've seen when making use of this particular style of reasoning is people will, if you show someone else's position to yield a contradiction, they will take it as a personal assault. Because you're saying, okay, let's accept what you're saying is true, but look, it leads to a contradiction that is utterly irrational. So either you accept this irrationality or your view is wrong. And I think sometimes people will respond to this by saying that, or treating you as though you are attacking them as individuals rather than their position. So I think it's hard to say practically when you should use this. So I just wanted to kind of preface my answer to this with that. In terms of the argumentative situation, you're trying to figure out a position or you're working in an argumentative context where people aren't going to take your arguments or objections as personal attacks. You might use this when you think an individual's position yields a contradiction or reduces to absurdity or yields a practical consequence that the proponent of the position would never accept. So the way you would do this is say, okay, person I'm arguing with, let's say I'm just going to grant your position is right. Then you draw out the contradiction in their view, and then you reason that their position has to be false. You see this a lot of times too in practical proposals, let's say about politics or what we should do in terms of public policy. There's a kind of assumption that if anyone puts forward a practical proposal or a political view, that it has to be palatable for people. People have to practically accept it. And you would use negation, elimination, and introduction by saying, okay, let's accept what you're saying is true, but look, it yields this horrible scenario that no one would accept. It's not practical. And given that all reasonable positions have to be practical, and this is not a practical proposal, then their position has to be wrong. So you can do this in the argumentative situation, and the style you would do it in is accepting what they say is true, and then trying to show that it yields to some impractical consequence or some kind of contradiction. Another way you might use it is as a style of self-critique. Let me give you an example. Suppose I think that my character or anyone's character is determined by what you do on a regular basis, your sort of habits. And also, let's say I don't give to charity or I don't give to anyone. But I might say, well, I think I'm charitable. So let's just for a moment assume that I have this property of being charitable. I'm not saying I am just going to assume it. Now, if I think that all character is determined by what I do on a regular basis and I don't give to charity at all or on a regular basis, then we might reason to that I am not a charitable person or charity is not a part of my character. And so I might use this particular method as ways of figuring out something about myself I could kind of write down all of my beliefs and try to sort of suss out any inconsistencies that are found in them, or sort of diagnose myself in terms of, the different properties that I have. All right, last question. The last question, and then I would say this is the most common question that I get, is can I see some more examples? Can you use this negation, elimination, and introduction rule in an example, in a proof? I want to see it one more time. So yeah, I can provide another example, and here it is. So let me just come up with one on the spot. I'm just going to make one up right now. And so this is going to be, let's say, P and Q and R, and let's say not P or not R, and then let's say it entails Z. So I want to prove that Z follows from these particular formulas. So I'll start the proof by simply writing out the formulas, setting up the proof. Here, I'm just taking the formula here and writing at line 1. And then at line 2, I'm going to write not P or not Q. And so this is line 2. I'm going to indicate that both of these are premises or propositions. And then I'm going to write the conclusion over here. I'm doing this just so I can remember it, so I don't have to look back up at this line at line 1. So my first step here is I'm just going to simplify this proof a little bit. I'm going to write P at line 3 and then Q and R at line 4. And both of these rules, or both of these formulas, are derived using the negation elimination rule from line 1. So now I'm looking at the two formulas I derived, and I'm also looking at these negation Q and negation P. And I'm saying, well, I think I could maybe derive a contradiction using line 2 and then maybe Q from line 4. So I'm going to reason to Q all by itself at line 5. And this is from 4 conjunction elimination. So at this point, again, I'm looking we have not P here and not Q here. And so maybe I can derive a contradiction. A rule you might not be familiar with is this disjunctive syllogism rule. I'm going to use it right here, which essentially says that one way of putting it is if you have a disjunction and the literal negation of one of the disjuncts, then you can reason to the other disjunct. So let me just write that rule over here. So the general form is you have phi or psi, and then you have the negation of one of these. So let's say negation of phi, then you can reason to psi. So there's different ways of formulating this rule, and one way is simply to say, provide these two formulas are negations of each other, you can reason to the other one. And so that's what I have here. You'll notice that at line 2 and 3, I have not P or not Q. So I have this not P or not Q. And then I also have P at line 3. And so now I can reason to the right side, which is not Q. So I'm reasoning to not Q at line 6 using lines 2 and 3 and this disjunctive syllogism rule. So at this point, you'll see that I have a formula Q and not Q, and I have this conclusion Z, which it doesn't matter how many elimination rules I'm going to use in lines 1 and 2, I still can't get this Z. So what I want to do is make an assumption. So I am going to assume the opposite of what I want, which is I'm not going to assume Z. This is a common mistake. You'll want to assume not Z. So I'm going to assume not Z right here. I'm going to make this assumption, and my goal of this assumption is to get a formula like P and not P, any formula in its literal negation. You'll notice that 5 and 6 are literal negations of each other. So at lines 8 and 9, I am going to simply reiterate those formulas into the proof. So I'm going to reiterate Q from line 5 using the reiteration rule, and not Q from line 6 using the reiteration rule. Now, what have I done? I've made an assumption, not Z, and then I showed that from this assumption, Q and not Q follows. So now I want to reason to, again, I don't want to reason to not Z or Z, but in this case, I'm going to reason to Z. So at line 10 here, I'm going to reason from this assumption and the subproof here. So line 7 through 9 using negation elimination. Now, this was a roundabout way of solving this proof. You might have actually started this proof by simply assuming line 7, that is, assuming not Z, and then deriving the contradiction Q and not Q in the subproof, that is, reasoning from lines 1 and 2, using these rules in the subproof. That would be another way of going about it. I sort of did it like this, just to illustrate that one particular tactic you might use, which is to try to simplify the proof, identify a contradiction in the premises, and then assume the opposite of what you want, which is not Z. So I hope this video was helpful. I hope it provided some context as to how you might use negation elimination in introduction, and I hope it also answered some questions that you may have had about the elimination and introduction rule.